Yesterday, a massive explosion rocked Beirut, Lebanon, killing at least 100 people and injuring thousands more. Videos of the incident were widely shared on social media platforms like Twitter, showing a massive mushroom cloud bursting into the air, followed by a destructive, fast moving shockwave. Multiple media sources are now reporting that a likely cause of the blast was a large amount of ammonium nitrate being stored in a warehouse in Beirut's port. Here with me now to take a deeper dive into the science of this chemical compound is Guy Colonna, an engineering director at NFPA. Thanks for taking the time to speak with me, Guy.
Thank you very much, Angelo. Angelo, it's my pleasure. Again, first, just express our sympathies to the people of Lebanon and Beirut, particularly. This is a huge industrial incident, it appears, and we really feel badly for what the country is going through. So, our thoughts with them.
Definitely. So first off, Guy, could you just explain to us what is ammonium nitrate and what is it typically used for?
Yep. Ammonium nitrate is one of a number of chemicals that are most commonly used as fertilizers. They're one of the ingredients that you find commonly in fertilizers that you can use on your own home or certainly for the larger agricultural applications. Chemically, ammonium nitrate is characterized as an oxidizer. And what an oxidizer does is that while it doesn't burn, it is capable of enhancing combustion if there is a fire that is adjacent to it or whatever. So the chemical formula of ammonium nitrate has lots of oxygen in it. So that's what makes it good in terms of functioning in terms of the agricultural purposes that it's usually used with. But when it's involved in incidents like this, it can cause some serious consequences, as we witnessed with the videos from yesterday's tragedy.
All right, and I'm glad you kind of clarified that point, Guy. I know that some of the reports right now we're seeing have said or described ammonium nitrate as a highly explosive material, and that's not technically accurate. So could you explain a little more about how ammonium nitrate can act as an oxidizer in an explosion like the one we saw in Beirut, and what some of the circumstances could be that led to that?
Yep. One of the aspects of working with oxidizers, whether it's ammonium nitrate or any other substances that are characterized as oxidizers, is that they are incompatible with certain materials. So basic handling precautions, storage precautions, use precautions deal with things like separating from those incompatible materials. One of the incompatibilities is exposure to heat, such as from a fire. And I know, again, looking at some of the social media reports, there were suggestions that there was maybe an early fire that led up to the ultimate explosions that everybody witnessed. Exposure of ammonium nitrate to something like a fire, open flame, things like that. Again, the ammonium nitrate does not burn. It's not flammable. It's not combustible. It doesn't become explosive. In other words, create an explosion like we witnessed until it becomes destabilized. Exposure to flames, fires, and things like that can start that process of heating it, destabilizing it. One of the things that happens is that it will, when it starts to become self-reactive through exposure to thermal sources like a fire, it will give off gases. Some of those gases are flammable, and therefore they will ignite, and then they will involve all of the oxygen that is in that chemical formula, the ammonium nitrate. Fires need three things. They need fuel, they need heat to be the ignition source, and they need oxygen. So once combustion starts, like with that initiating fire, if that's what really happened, then the oxygens that are in the ammonium nitrate in that oxidizer, they just add that extra oxygen to the fire and cause it to become more intense.
Okay. All right, Guy, thanks for that explanation. So in terms of NFPA codes and standards that are relevant to the safe handling or storage of ammonium nitrate, what are there?
Yep. NFPA has NFPA 400, which is our hazardous materials code. And Chapter 11 in NFPA 400 speaks specifically to requirements uniquely for this particular material, ammonium nitrate. The requirements that are in NFPA 400 on ammonium nitrate actually underwent some fairly rigorous updates as a result of a tragedy in the United States back in April of 2013 at the West Fertilizer Facility. That fertilizer facility made fertilizers and therefore had stockpiles of ammonium nitrate as part of their formulation of fertilizers for large agricultural applications. And there was an incident there that occurred where large quantity of ammonium nitrate ultimately became involved in a combustion reaction and produced an horrific explosion, resulting in fatalities and serious damage to the town of West Texas. With the lessons learned from that investigation into the West Texas incident, a number of changes went into NFPA 400 and Chapter 11 specifically. Some of the things that all of our codes and standards that deal with hazardous materials will typically address when you're trying to manage the hazards that are inherent in those materials start with managing the quantity. So in the case of NFPA 400, Chapter 11 imposes additional safeguards when you exceed 1,000 pounds. Now, from what I've read in the reports, they're talking something like 2,750 tons. So clearly, there should have been increased safeguards in the storage of that confiscated ammonium nitrate that's been reported as being in the warehouse in Beirut. Second thing would be that you would have certain kinds of construction associated with the warehousing, and you wouldn't have incompatible materials like oils and greases and things like that, because that causes oxidizers to self-react. And the other thing that would be important is that there would be separation distances from the warehouse, say, to an adjacent structure, but also to populated areas. And again, from what we can see in the aftermath of this incident, probably those separation distances didn't exist.
Okay. And so you mentioned the West Texas incident, obviously, but in the United States, I think most people would probably be familiar in terms of an example of an ammonium nitrate explosion with the Oklahoma City bombing in 1995. So have there been other notable incidents as well involving ammonium nitrate in the U.S. and abroad?
So again, before going on to the ammonium nitrate itself, the Oklahoma City incident in 1995, that was not fertilizer grade ammonium nitrate. That is what is called ANFO, ammonium nitrate fuel oil, ANFO. What happened there was that they took the oxidizer, ammonium nitrate, and they combined it with the fuel oil, and that changes it in terms of its characteristics, but also it changes it how it's classified. So all of a sudden, the oxidizer, ammonium nitrate, that we would typically see in the fertilizer applications, it becomes now classified as an explosive. So that is why that material behaved that way, because all of a sudden, by mixing it with the fuel oil, we had changed its characteristics, and it was now chemically classified no longer as an oxidizer, but as an explosive. There was a major incident in the U.S. in 1947 in Texas City involving ships that in the port of Texas City that were carrying ammonium nitrate as cargo. And there were some issues with fires starting on the ship. Again, the ammonium nitrate by itself is not the fuel in the combustion reaction. It is an oxidizer. However, because of the fire that was on the ship, it exposed the ammonium nitrate. It becomes unstable. It slowly reacts, and eventually that reaction turns it into the ability to become react in an explosible way. And so that's what happened, and it blew up two ships and killed a number of people. in the port of Texas City and also the adjoining homes, largely because a lot of people came to see what the explosions were down in the port, and they got closer from a vantage point standpoint. So again, it goes back to the importance of those separations to populated areas. Not knowing what was going on, the people actually came closer to the area and became involved in some of the damage and devastation that resulted from subsequent explosions.
All right. And in general, Guy, regardless of the commodity being stored, we have seen a number of global tragedies result from the improper storage of chemicals or hazardous materials. What are your thoughts on that, and kind of, what do you think, some of the ways perhaps NFPA could assist in helping to stem this issue?
Yep, and I think it would go back again to kind of the fundamental premises of any of our hazardous materials documents, whether it's liquids, gases, or solids, like explosives or pyrotechnics. And that is that, again, you're going to start by basing your protections on quantities. If you have smaller quantities, and in our standards and in the building and fire codes, they use the term MAQ, maximum allowable quantity. That's a trigger threshold. It's not a maximum. It's just a threshold below which you are using a quantity that requires less rigorous protections. The minute you need to go above that MAQ, then you start basically requiring increased protections. The increased protections could be putting it in its own structure, in its own building, what we call detached construction. It could also be putting in active detection and suppression for certain materials. It also could be increasing the separation distances. So that's, and it comes with, though, understanding what you have at the beginning. Now, as I understand in this incident in Beirut, the material appears to have been confiscated as being illegally transported into the country. It was being stored. It has been stored for what I've seen reported to be 6 years. Questions would be, what was the quality of that storage, and was the material being monitored? And did people understand, as other things were happening in the port area, whether they were bringing incompatible materials in there? Something like this happened in Tianjin, China in 2016. One of the compounds that was in warehouse storage in the port of Tianjin was ammonium nitrate. When you read the investigation record there from that incident, something like 170 people were killed there. A number of them were first responders. Unfortunately, because they were so close, they responded first before they understood what the consequences were and what the real incident involved. But what had happened over time was, while the warehouses there were initially permitted for certain materials and certain quantities of materials, over time, people stopped paying attention to the people managing the warehousing and the port area, lost track of the types of materials and also the quantities. And so they started increasing the quantities beyond what was originally permitted and changing some of the commodities. So they started putting incompatible materials in the same storage area. So all of this comes down to things that we have and we highlight in the fire and life safety ecosystem, where it starts with the government having requirements and then making sure that those requirements are understood by everybody in the operational setting. So whether it's the port managers or the warehouse managers, the people who are bringing the chemicals in and out of the area, the workers in the area, but also the public. And in Tianjin, for example, the responders. Now in Beirut, I'm not sure how much of a response present was possible because of the how instantaneous the damage occurred and the degree of the damage. But in Tianjin, as I said, the fires that started there, the fire department was essentially across the street, so they were immediately able to respond. but perhaps all of that information that should have been managed from a government perspective, following and complying with codes and standards like NFPA 400, would have been shared with those responders so that they would have understood specifically the nature of the materials. And with an oxidizer fire, for example, once an oxidizer gets involved, everybody is trained to understand that it's very difficult to fight an oxidizer fire.
Okay. All right. Well, thank you, Guy, for taking the time today. Is there anything you would like to add?
I think every time I see tragedies like these, it comes back to understanding the material, understanding how much you have, where it's being stored, and what safeguards are in place. And then with that understanding, making sure that information gets disseminated to the right places, including the emergency responders who can both plan in terms of pre-planning, but also be more aware if something happens and they have to respond.